The 777 air conditioning system is similar to those in other Boeing airplanes. The system provides conditioned air and recirculated air at controlled temperatures. The system includes two packs: the trim air system and two upper and two lower recirculation fans. The air conditioning packs receive hot bleed air from the engines, from the APU, or from ground air sources. The packs cool the bleed air before passing it to the conditioned air manifold. Conditioned air can also be added to the conditioned air manifold by ground air sources. Conditioned air is then distributed to the flight deck and from the manifold to zones A through F in the cabin. Hot trim air from the bleed air system is mixed with conditioned air from the manifold. This controls the temperature in each zone. Upper and lower recirculation fans augment cabin ventilation. This allows packs to operate at reduced flow settings during cruise. It saves fuel. Controls for the air conditioning system are located on the overhead panel. The air synoptic shows various air conditioning system operations. Select the air synoptic. These switches control operation of the left and right packs. When the switches are off, the off lights are illuminated, and the ICAS advisory messages pack left and pack right are displayed. This indicates that the pack valves are closed. The packs are normally switched off as part of the secure procedure. They should turn on again during pre-flight. Turn on the packs. Notice that the off lights extinguish, and the ICAS messages pack left and pack right are no longer displayed. Here's what's happening with the system. With auto selected, a flow control valve opens. This allows bleed air to enter the pack. Airflow to the packs is shown on the synoptic by green flow lines. Hot bleed air entering the pack is cooled by heat exchangers. Next, the air enters an air cycle machine where the air is cooled to the temperature of the zone requesting the coolest air. The cooled air is then supplied to the conditioned air manifold and distributed to the zones in the airplane. These switches control the trim air system. When the switches are off, the fault lights illuminate, and the ICAS advisory messages trim air left and trim air right are displayed. This indicates the valves are closed. Push the left and right trim air switches to on. When the trim air switches are on, the fault lights extinguish. The ICAS messages disappear, and the valves open. This allows hot trim air to mix with cool conditioned air to modify temperatures in all zones except in the zone that requires the coolest air. This selector controls the flight deck temperature. It is normally left in the auto range. The target temperature for the flight deck is shown on the synoptic. The actual flight deck temperature is also shown. In the auto range, you can adjust the flight deck temperature from 18 to 29 degrees Celsius. Increase the temperature to 27 degrees. Notice that the target temperature increased to 27 degrees, and the flight deck trim air valve moved toward W or warm. After a short period of time, the actual flight deck temperature also reaches 27 degrees. Now decrease the flight deck temperature to 18 degrees. Notice that the target temperature decreased to 18 degrees. The trim air valve moved toward C or cool, and the actual flight deck temperature decreased to 18 degrees. Now, rotate the flight deck temperature selector to man or manual position. With the selector in manual, you control the trim air valve. The manual position is used when automatic temperature control is not available. Notice the target temperature is blanked. Rotate the selector toward W and notice what happens to the flight deck trim air valve and the temperature on the synoptic. As you can see, the trim air valve opened to let in more hot trim air, and the actual flight deck temperature increased to 24 degrees. The flight deck temperature selector is spring-loaded to the 6 o'clock position. You can rotate the selector back and forth to set the trim air valve position. Then as the flight deck approaches the desired temperature, you can make any desired adjustments. Now rotate the selector back to the auto range. This control sets the master temperature for the main cabin. The range of temperature control is from 18 degrees to 29 degrees Celsius. The master temperature setting becomes the baseline temperature for air supplied to the main cabin. With the control at mid-position, the master temperature is approximately 24 degrees and is shown on the synoptic. The temperature in individual zones can be further adjusted plus or minus 6 degrees from the master temperature. The temperature of individual zones is modified at the Cabin Management System panel, which is located in the main cabin. Watch as a flight attendant adjusts a cabin area temperature. First, the attendant selects the cabin area. Notice that the area target and actual temperatures that are displayed on the attendance panel match the temperatures shown on the synoptic. Next, the flight attendant adjusts the area target temperature down to 21 degrees, and the new target temperature appears on the synoptic. The system automatically adjusts until the actual temperature reaches the target temperature. Watch what happens when the cabin temperature control is set at a value other than the 24-degree mid-position. Set the master temperature to 21 degrees. The flight attendant now attempts to set the temperature to 29 degrees. Notice that the target temperature stops increasing when it reaches 27 degrees. The air conditioning system only allows a 6-degree temperature difference from the master setting. The system automatically adjusts until the actual temperature reaches the target temperature. Remember, regardless of the master temperature setting, the flight attendants cannot adjust the temperature in any of the individual zones to less than 18 degrees. They cannot adjust the temperature in any zone to more than 29 degrees. And finally, the system only allows zone temperature adjustments plus or minus 6 degrees from the master setting. These switches control the upper and lower recirculation fans. With either switch off, the ICAS memo message "Recirculation fans off" is displayed. The upper and lower recirculation fan switches are normally left in the on position. Push both upper and lower recirculation fan switches to on. With the switches on, the memo message is no longer displayed. Air for the upper recirculation fans comes from the area above the main passenger compartment. The air is recirculated to the zone ducts. Air for the lower recirculation fans comes from under the floor area. The fans recirculate the air to the conditioned air manifold. The upper and lower recirculation fans augment airflow throughout the cabin. Fan operation is automatically controlled by system logic. The switch positions for pre-flight are listed here. Configure the panel for pre-flight. The switch positions for securing the airplane are listed here. Secure the airplane. This switch controls the equipment cooling system. When the equipment cooling switch is off, override is illuminated, and the ICAS advisory message, Equipment Cooling Override, is displayed. The equipment cooling switch is normally left in auto. Select Auto. When Auto is selected, the override light extinguishes, and the ICAS message is no longer displayed. Here's how the system works. In Auto, a supply fan starts and begins to pull air from the forward cargo bay into the system. Air from the cargo bay enters the ducts and passes by temperature and smoke detector probes. These probes detect fan failures by the lack of airflow. They also check for the presence of smoke in the ducts. The override valve is normally open to allow air to flow in the ducts, but it closes for certain non-normal conditions, as you will see later in this lesson. Cooling air enters the flight deck panels, displays, and equipment racks from below, and is drawn into the exhaust ducts by a vent fan. The warm air passes another smoke detector that detects smoke from the electrical equipment. Air is then exhausted into the forward cargo compartment to heat the compartment. The temperature is controlled by valves that open and close. When the air in the compartment is warm, equipment cooling air is vented near the forward outflow valve. The system automatically maintains the temperature in the forward cargo compartment. Selectors for the aft and bulk cargo compartment temperatures are located on the overhead maintenance panel. This selector sets the temperature in the aft cargo compartment. This selector sets the temperature in the bulk cargo compartment. Neither selector is accessible from the pilot's seated position. Note that the temperature in the aft and bulk cargo compartments is shown on the synoptic. To see how the aft cargo compartment is heated, select Low on the aft cargo temperature selector. When the aft cargo compartment temperature selector is in low, the shutoff valve opens. The temperature control valve opens if the temperature in the compartment is less than 4 degrees Celsius, but not greater than 10 degrees Celsius. In our example, the compartment temperature is 3 degrees. Therefore, the temperature control valve opens, allowing bleed air into the aft cargo compartment. When the temperature reaches 10 degrees Celsius, the temperature control valve closes. From then on, the system opens and closes the temperature control valve, maintaining a temperature from between 4 and 10 degrees in the compartment. Now, select High on the aft cargo compartment temperature selector. Selecting High allows the system to automatically maintain the temperature in the compartment from between 18 and 24 degrees Celsius. The bulk cargo compartment heating is similar to the aft cargo compartment heat, except for the addition of a bulk cargo ventilation fan. The fan operates only when the bulk cargo temperature selector is in the high position. Select High on the bulk cargo temperature selector to see how the system works. As you saw in the aft cargo compartment heat system, selecting High opens the shutoff valve and also the temperature control valve. In this case, it also turns on the ventilation fan. The system then maintains the temperature in the bulk cargo compartment by a process similar to the process for the aft cargo compartment. The low setting sets the temperature range from 4 to 10 degrees Celsius, and the high setting maintains the temperature from 18 to 24 degrees Celsius. Controls for the foot and shoulder heaters are located here on the sidewall panels. This selector operates the foot heater. The foot heater is an electrically heated plate mounted on the floor beneath the captain's and first officer's rudder pedals. Select Low on the foot heater selector and watch the result on the heated plate. With Low selected, the temperature of the plate is automatically maintained. Now, increase the temperature on the foot heater by selecting High. As you can see, selecting High increases the temperature of the foot heater, and now the new temperature is automatically maintained. Next, let's discuss the shoulder heater. This control operates the shoulder heater. The control operates an electric heater in the side window's air supply. Increase the temperature to see how the system works. As the heating element heats up, it warms the air flowing to the side windows. Now increase the temperature to the shoulder heater. As you can see, the shoulder heater control is continuously variable, while the foot heater selector has only two positions. The temperature regulation of both the foot and shoulder heater is automatic. There are non-normal ICAS messages associated with trim air, packs, equipment cooling, and cargo heat. We begin with the trim air non-normals. The ICAS advisory messages trim air may be displayed for several reasons. The trim air switches could be off, a respective trim air valve could have failed closed, or there could be a zone duct overheat. In all cases, trim air is shut off to the respective zones. In this example, the ICAS advisory message trim air left is displayed due to a zone duct overheat. The respective trim air valve closed automatically, and the fault light in the trim air switch illuminated. The system may be reset after time is allowed for the zone duct cooling. Push the air conditioning reset switch. Pushing the reset switch resets the system. If the message comes up again within a short period of time, the respective trim air system is turned off. Turn off the left trim air switch. These messages are associated with the air conditioning packs. The ICAS advisory message pack may be displayed for several reasons. The pack switches could be off, the pack's flow control valves could have failed closed, bleed air may have been shut off to the pack, or the pack could have overheated. In all cases, the pack is automatically shut off. In this situation, the ICAS advisory message pack right is displayed due to a pack overheat. The respective pack valves closed, shutting off bleed air to the pack, and the off light in the pack switch illuminated. The system can be reset after time is allowed for pack cooling. Push the air conditioning reset switch. Pushing the air conditioning reset switch resets the system. If the message comes up again, the respective pack is turned off. Turn off the right pack. The pack mode ICAS advisory message displays if the air cycle machine fails, or when other pack components fail in such a way that the system is able to automatically revert to standby cooling mode. If that happens, standby cooling appears on the synoptic. Pack operation depends on the heat exchanger's ability to provide sufficient cooling. If the airplane is in an area of insufficient cooling, bleed air to the pack is shut off. When the airplane is in an area of sufficient cooling, the pack valves automatically open and bleed air is cooled by the heat exchanger and is added to the conditioned air manifold. When the airplane sees favorable conditions, bleed air is shut off to the pack. This minimizes excessive heat buildup in the cabin. Remember, this operation occurs automatically. These messages are associated with the equipment cooling system. The ICAS advisory message, Equipment Cooling, can only display on the ground. The message is caused by supply fan failures or low airflow, by excessive cooling air supply temperature, or if both override valves are not in their commanded position. Any of these failures activates the ground crew call horn located in the wheel well. The ICAS advisory message Equipment Cooling Override displays if any of the following conditions occur: smoke detected in the ducts, low airflow, system faults, standby power operation, or arming the forward cargo firearm switch. With the message displayed, override appears in the equipment cooling switch. In all cases, the supply and vent fans stop. The override valve opens, and the forward cargo heat valve closes. Air for equipment cooling now flows through the equipment compartment and out the override valve. The amount of airflow through the equipment compartment varies with differential pressure. After a short period of time, the system is reset. Turn the equipment cooling switch off, then back to auto to reset the system. If the message reappears, the system reconfigures the valves and differential pressure cooling would again cool the equipment. Minimize flight time at low altitudes since sufficient cooling air for the equipment and displays may not be available. As a result, equipment could fail. These messages are associated with the cargo heat system. The ICAS advisory messages Cargo Heat Aft and Cargo Heat Bulk are similar. For our example, let's consider the Cargo Heat Aft ICAS message. In this example, the Cargo Heat Aft message may be displayed for system failures, such as valves feeling closed, lavatory galley fan failure, or other component failures, such as the temperature probe. Regardless of the failure condition, cargo heat for the affected compartment is inoperative. Crew action is not required.